So this week I'm going to talk just really briefly about how the ear works and how hearing works. Hearing loss is one of the most common sensory impairments there is, and the World Health Organization estimates about 5% of the world's population has profound hearing loss or is deaf. Compare this to less than 0.02% of the world's population is afflicted with blindness. So this is what we call the auditory pathway. Over here you have the ear. This is what's called the external ear. This is where the Q-tip can go in but probably shouldn't. Here is what we call the eardrum or the tympanic membrane. And then we have the middle ear, which is made up of very small delicate bones called ossicles. And then here we have the inner ear, which consists of the cochlea, which is this shell-shaped bone, which is connected to what's called the vestibular system. The vestibular system shares fluid with the cochlea, and it's responsible for things like detecting whether you're in balance or not. So oftentimes when you have some type of hearing impairment that's associated with the cochlea, you also have balance problems or what's called vertigo. And then we have the cranial nerve, which heads out from the auditory pathway into the auditory cortex, that part of the brain that's responsible for processing sound information. All sorts of things can go wrong in hearing impairment. Everything from just plain earwax to getting an infection in your middle ear and bursting that eardrum or that tympanic membrane. Today that can be replaced. But most of the very serious problems occur in the cochlea. So how this whole auditory pathway works is really fascinating. Sound waves come in through the external ear and they reach this membrane, right, which acts as a kind of drum. And that drum sends vibrations to the ossicles. And this bone here, which contacts with the cochlea, is called the stapes. And so those ossicles are moving back and forth as those sound waves, as they're reacting to the vibrations from the eardrum. And the cochlea is a bony structure, but it has a little window called the oval window. The stapes pushes in and out in that little window, which is actually a membrane. So it transfers those waves into the cochlea. And in the case of the cochlea, that's just pure fluid. So it's moving fluid around this bony structure. So if something goes wrong with the stapes, you can actually go in and surgically replace it. Here's just a look at where this auditory canal is on your skull. So it's a small hole located behind your mandible, behind your jawbone. So inside the cochlea, if we rolled it out and then spread it open, we would see something like this. So this central part of the cochlea is called the cochlear duct. And inside the cochlear duct are something called hair cells. And these are sensory cells that respond to different frequencies of sound. And there's outer hair cells and there's inner hair cells. The outer hair cells respond to sound and they are connected by a membrane to the inner hair cells. And it's those inner hair cells that send the message on to your brain, to the auditory cortex, where it is decoded. And there is a huge amount of neural devotion, a lot of neurons dedicated to processing incoming sound in what's called the primary auditory cortex. This is one of the reasons why it's so hard for machines and robots to understand and decode human speech. Unfortunately, while you can replace the tympanic membrane and you can replace the stapes, you can't replace outer hair cells. And this is just a look at how those outer hair cells work in combination with the inner hair cells. There is a new technology called cochlear implants that have helped some people, especially people who have actually heard during part of their lifetimes, to regain some hearing. So it's really important to take care of those outer hair cells. And even things like very loud noises can just shear off those outer hair cells. And without them, you're unable to detect certain frequencies because there's different parts of the cochlea interpret different frequencies of sound. So if they're lost, you just will not hear those frequencies anymore. So something on the order of 110 decibels or repetitive listening to 80 and 90 decibels can have a serious impact on those outer hair cells and ultimately your hearing. It's really unknown what effect things like earbuds or playing earbuds loudly is going to do to people's hearing.